Today's lesson is on the greatest common factors, also known as GCF. Today's goal is that students will find the greatest common factor of a set of numbers by listing all the factors of the numbers. So let's just start with a review so far of what we've done this unit. So we're going to start by placing the numbers that are given below in the Venn diagram, sorting them based on factors of 9 and on factors of 12. So on this side, let's first think of all the ways that we can multiply to get to the number 9. So we know we can do 1 times 9. 2 times nothing will give us 9. We know we could do 3 times 3. 4 times something will get me 5, 6, 7. We know that based on the theory that we learned the other day on this chart, our numbers are already now matching. So the next one that we are going to come across is going to be 9 times 1. So we know that factors of 9 are going to be 1, 3, and 9 itself. Now on this side, let's do factors of how we could get to 12. So we know that we could do 1 times 12. We know we could do 2 times 6 to get to 12. We know we could do 3 times 4, which means we could also do 4 times 3. Now we don't need to really go any further because the chart right here is just going to repeat its numbers in the opposite order. So we now can then say that the factors of 12 are 1, 2, 3, 4, 6, and 12 itself. So we're now going to look for common ones between the two. So we can see that 1 goes into both 1 and 12. We can see that 3 can go into 1 and 12. And that is the only two numbers that they have in common. So 1 and 3 can both be considered factors of 9 and 12. And then all the other numbers are on their own side. So 9 goes on this side. We keep 2, 4, 6, and 12 on this side. So let's start with an exercise on your whiteboards just to get you guys thinking today. So what factors do list all the factors of 16 and the factors of 20 in a chart like we just did on the previous slide, and then you're going to sort the numbers from 1 to 20 into the Venn diagram below. When you're done, you're going to resume your slide. So let's just take a quick break to think about and remember what lowest common multiple is. The lowest common multiple is the smallest number that is a multiple of both numbers, or the smallest number that is a multiple common to both. So that was the very first lesson we did in this unit. So we can say that as lowest common multiple, we write it as LCM. Now today we're focusing on the greatest common factor. So what do you think the greatest common factor of two numbers means? Well, it is the largest or the greatest number that is a factor of both the numbers. It is the greatest factor that the two numbers have in common. So now let's do an exercise together. Let's do A together, and you can do B on your own. So we're going to find the greatest common factor of 12, or 9 and 12, sorry. So we know that based on the charts, the greatest common factor of 9 that we found, so we had for common factors, we had 1, 3, and 9. And then for 12, we had on the other side, we had 1, 2, we had 3, 4, 6, and then 12 itself. So we would say here that the greatest common factors of 9 and 12 would be the number 3. It is the greatest common factor between the two of them. Now, based on how you sorted for 16 and 20 on the previous slide, what would that greatest common factor be? So remember, you can make a chart to find all the factors of a number, and you don't have to list all the possible numbers. You don't need to go any higher than the first half, and in fact, you can stop the first time you get to a number that is in a pair because you've already found that previously, just like I was explaining before. Once you've found the greatest common factor for 16 and 20, continue on. So now we're going to list the greatest common factors of 24, 25, and 30, and then we're going to find the greatest common factor of them. So first, let's list all of the factors of 24, 25, and 30 in a chart. And then you're going to tell me which one find the greatest common factor of 24 and 25, 24 and 30, 25 and 30. When you're done, we will go over the answers here, so just continue on. Great job if you did the work for these. So you will have found that the greatest common factors of 24 and 25 itself. So for so for 24 and 25, the greatest common factor there is going to be 1. That's the only number they have in common. For 24 and 30, the greatest common factor is going to be 6. And then for 25 and 30, the greatest common factor should have been 5 that you found. So let's go on to exercise number 2 here. In your chart on a whiteboard, you're going to list all of the factors for 44, for 45, and for 60 and 66. And then you're going to find the greatest common factor of the following, and then we'll go over these answers together. So continue on once you have solved all of these answers. You should have found that the greatest common factor for A for 44 and 45 is 1. The greatest common factor for 44 and 60 is 4. Greatest common factor for 44 and 66 will have been 22. The greatest common factor for 45 and 60 is 15. For 45 and 66 for E, the answer was 3. And for F, the answer was 6. So here we have 3 as a factor of 6. So let's remember that 3 is a factor of 6 precisely because there is a number that multiplies with 3 to get to 6. So that is exactly what it means for 6 to be a multiple of 3. So let's show this in a sentence then. So we could say 3 is a factor of 6 because we know that 3 times 2 gives us 6. Therefore, 3 is a factor of 6. But we can also say that 6, sorry about my writing, is a multiple of 3. Okay. So we're going to write some sentences that means the same thing as the given sentence, but uses the word multiple instead of factor. So let's look at A together, and then you can continue on with B afterwards. So we can say that 4 is a factor of 20, but we could also then say that 20 is a multiple of 4. So all I'm doing is I'm flipping that around and just switching out the word factor for multiple. I want you to do B and C on your whiteboard together. Now, we can also see that, let's just first start with the multiples of 6. So if I asked you to list all of the multiples of 6, reality is you could go forever because you could just skip count. So 6, 12, 18, 24, you could continue on forever and ever and ever, never run out of numbers by skip counting by 6. There's an infinite amount of multiples of 6. So let's repeat this for the factors of 6. So for the factors of 6, you can only have 1 times 6. Wow, that's a big 6. You can only have 1 times 6 to get to 6. You could have 2 times 3, and that's the only ways that you can get to 6. So the factors of 6, we would say, are 1, 2, 3, and 6 itself. So it's really important that we notice that for multiples, you can have many, many multiples. They can go on forever and ever and ever. But we can have few factors. There's only so many certain factors for each number. So remember that by thinking M, many, and M, multiples, or F and F for few factors. Okay, let's do another exercise here. So we're going to fill in the blanks with either multiples or factors. So let's do A together, and then you can do B and C on your own. So let's look at this. The blank of 8 are 0, 8, 16, 24, 32, ... Well, those dots are showing that we're skip counting by 8s, and you can skip count forever and ever and ever. So we know that the answer then is the multiples of 8 are, because you can go on forever and ever and ever. There's many multiples. Okay. So except for 0, the multiples of a number are always at least as big as the number. but the factors are never more than the number itself. So we see here that 8, the numbers listed behind it go on much higher than the number 8 itself. So we know that one's multiples. Now I want you to continue on with the examples B and C and D on your whiteboards. Then you're going to continue on. So this is just what I just went over. So except for 0, the multiples of a number are always at least as big as the number, and the factors are never more than the number you're trying to solve for. So let's continue on for this exercise. So it says decide whether each number is a multiple or a factor of 6. So for 18, is 18 a multiple of 6 or a factor of 6? Well, based on what I just told you, 18 is larger than the number 6 itself, so 18 has to be a multiple. We can only get to 18 when we're skip counting forever and ever and ever. 2, is it a multiple or a factor? 2 would be a factor because we could do 2 times 3 to get to 6. What would 3 and 12 be? I want you guys to try and finish C and D on your own. So let's start now by listing all the factors of 20. So to list the factors of 20, let's think of all the ways we can get to 20. We know we can do 1 times 20. We know we could do 2 times 10. We could do 4 times 5, which means I'm going to get 5 times 4 as well. 6, 7, 8, 9, they don't all work. 10 goes on the other side. So those are the factors of 20. There's only a few of them. Now we're going to list the multiples of 3 up to the number 20. So multiples of 3, you're going to be skip counting all the way till we get to 20. So 0, 3, 6, 9, 12, 15, 18. I can't go any higher because then I would go over 20 and I only want to go to 20. So are any of the numbers that are here are both a factor of 20 and a multiple of 3? Do any of these numbers show up in the same lists? No. So now let's now look for if there are any numbers that are both a factor of 20 and a multiple of, sorry, moving on. So we have all the factors of 20 here. Now we're going to look for multiples of 5 up to the number 20. So let's skip count by 5s and see what we get. 0, 5, 10, 15, 20. Now, are there any numbers that are both a factor of 20 and a multiple of 5? The answer is yes. We have the number 5, 10, and 20 that are all similar in these two lists. So now on your whiteboards, I want you to try and find numbers that are both a multiple of 8 and a factor of 24, a multiple of 6 and a factor of 24, a multiple of 2 and a factor of 10. So remembering what we just went over, factors are few, multiples are many. So can a number be both a multiple of 24 and a factor of 8? The answer is no, but how do we know this? Well, we know all the multiples of 24, except for 0, are at least 24 itself. The factors of 8 are all at most 8, so no number can be both a multiple of 24 and a factor of 8 itself. So my question here is, what number is both a multiple and a factor of 8? So let's start by listing all of the factors of 8. So the factors of 8. So for factors of 8 would be how we could make 8. So 1, we could do 2 times 4, and then 8 itself. Those would be the factors of 8. Excuse me. And then you're going to choose the one that's also the multiple of 8. So if we skip count by 8s, the only multiple of 8 that we have here is 8 itself, because if I skip counting, I'm going to say 0, 8, 16. So is 1 also a multiple of 8? So what number is both a multiple and a factor of 9, 10, 1,000? Well, the answers are just 9 itself is a multiple and a factor of 9. 10 itself is a multiple and a factor of 10. 1,000 itself is a factor of and a multiple of 1,000. This is because the factors of a number are never greater than the number. but the only multiples of a number that are not greater than the number are 0 and the number itself. So since 0 is never a factor, the only multiple that can